Dimmers can generate electromagnetic interference, often called EMI, that is picked up by radio receivers, causing static. This is more common with incandescent lights because dimmer switches rapidly cut off power to the bulbs, creating voltage spikes. To solve this problem, firstly, consider installing an EMI filter. Insert a ferrite choke or an EMI filter in line with the power cord of the radio. These devices help suppress high-frequency noise. Secondly, use a different type of dimmer. Avoid using triac dimmers, as they generate more EMI than other dimmer types. Consider using leading-edge dimmers, which cut off power to bulbs at a lower voltage, reducing EMI. Electronic dimmers, such as pulse-width modulation, often called PWM, and metal oxide semiconductor field effect transistor, often called MOSFET dimmers, generate less EMI. Here are some other tips. Place the radio as far away from the dimmer and light fixtures as possible. Try using light-emitting diode, often called LED, or compact fluorescent lamp, often called CFL, bulbs, as they generate less EMI than incandescent bulbs. Check for any loose or damaged electrical connections between the dimmer, light fixtures, and radio. Consider using a power conditioner or surge protector to filter out EMI from the entire electrical system. Let's look at each of these solutions in more detail. EMI filters work by attenuating high-frequency noise that travels along the power lines. These filters typically consist of inductors and capacitors arranged in a way that blocks high-frequency signals while allowing the alternating current power to pass through. A ferrite choke is a simple type of EMI filter that consists of a magnetic core wrapped around the power cord. The ferrite material absorbs high-frequency noise and converts it into heat. More sophisticated EMI filters may include multiple stages of filtering and shielding to provide better noise reduction. When selecting an EMI filter, it's important to choose one that is rated for the correct voltage and current. You should also consider the frequency range of the noise that you are trying to suppress. Different EMI filters are designed to work best at different frequencies. Replacing a triac dimmer with a leading-edge dimmer or an electronic dimmer can significantly reduce EMI. Triac dimmers are the most common type of dimmer switch, and they work by chopping the alternating current waveform, which creates sharp voltage transitions that generate EMI. Leading-edge dimmers also chop the alternating current waveform, but they do so at a lower voltage, which reduces the magnitude of the voltage transitions and the amount of EMI generated. Electronic dimmers use different techniques to control the brightness of the lights, such as pulse-width modulation. Pulse-width modulation dimmers rapidly switch the power on and off, but they do so at a high frequency that is less likely to generate EMI. Metal oxide semiconductor field effect transistor dimmers use transistors to control the current flow into the lights, which allows for smooth and continuous dimming without generating significant EMI. When choosing a dimmer switch, it's important to consider the type of lights that you will be using. Some dimmer switches are designed to work with specific types of lights, such as light-emitting diode or compact fluorescent lamp bulbs, while others are more general purpose. You should also consider the wattage of the lights that you will be dimming. Dimmer switches are rated for a maximum wattage, and using a dimmer switch with lights that exceed this wattage can damage the dimmer switch or the lights. Moving the radio away from the dimmer and light fixtures can reduce the amount of EMI that is picked up by the radio receiver. The strength of the electromagnetic field decreases with distance, so moving the radio further away from the source of the noise can significantly reduce the amount of interference. You can also try orienting the radio antenna in a different direction. The antenna is most sensitive to signals that are aligned with it, so changing the orientation of the antenna can reduce the amount of noise that is picked up. Light-emitting diode and compact fluorescent lamp bulbs generate less EMI than incandescent bulbs. Incandescent bulbs produce light by heating a filament, which generates a broad spectrum of electromagnetic radiation. Light-emitting diode and compact fluorescent lamp bulbs use different technologies to produce light, which generate less electromagnetic radiation. In addition, light-emitting diode and compact fluorescent lamp bulbs are more energy efficient than incandescent bulbs, so they can save you money on your electricity bill. Checking for loose or damaged electrical connections can help to reduce EMI. Loose connections can create sparks, which generate electromagnetic radiation. Damaged wires can also act as antennas, radiating noise. Inspect all of the electrical connections in the area around the dimmer, light fixtures, and radio, and tighten any loose connections. Replace any damaged wires. A power conditioner or surge protector can filter out EMI from the entire electrical system. Power conditioners are designed to provide clean and stable power to electronic devices. They typically include filters that remove noise and voltage spikes from the power line. Surge protectors are designed to protect electronic devices from voltage surges. They typically include components that clamp the voltage to a safe level, preventing damage to the devices. While surge protectors are primarily designed to protect against voltage surges, some surge protectors also include EMI filters. When choosing a power conditioner or surge protector, it's important to choose one that is rated for the correct voltage and current. You should also consider the amount of protection that it provides. Some power conditioners and surge protectors offer more protection than others. In addition to these solutions, there are a few other things that you can try to reduce EMI. Make sure that the dimmer switch is properly grounded. A good ground connection can help to reduce noise. Use shielded cables for all of the electrical connections in the area around the dimmer, light fixtures, and radio. Shielded cables can help to block electromagnetic radiation. Keep the power cords of the dimmer, light fixtures, and radio as short as possible. Long power cords can act as antennas, radiating noise. If you have tried all of these solutions and you are still experiencing static interference, you may need to consult with a qualified electrician. An electrician can help you to identify the source of the noise and recommend the best solution. The electrician can also check your electrical system to make sure that it is properly grounded and that all of the connections are tight. Understanding the technical aspects of electromagnetic interference can help you to troubleshoot and solve problems with static interference. The electromagnetic interference is a type of disturbance that affects electrical circuits. It is caused by electromagnetic fields that are generated by electrical devices. Electromagnetic fields can be either electric fields or magnetic fields. Electric fields are created by voltage and magnetic fields are created by current. Electromagnetic interference can be transmitted through the air, through wires, or through other conductive materials. There are two main types of electromagnetic interference, namely conducted electromagnetic interference and radiated electromagnetic interference. Conducted electromagnetic interference is transmitted through wires or other conductive materials. Radiated electromagnetic interference is transmitted through the air. Electromagnetic interference can cause a variety of problems, including static interference, data corruption, and equipment malfunction. To reduce electromagnetic interference, it is important to use shielded cables, filters, and other techniques to block electromagnetic radiation. It is also important to make sure that all of your electrical equipment is properly grounded. Dimmer switches generate electromagnetic interference because they chop the alternating current waveform. This creates sharp voltage transitions that generate high-frequency noise. The amount of electromagnetic interference generated by a dimmer switch depends on the type of dimmer switch, the type of lights that are being dimmed, and the amount of current that is flowing through the dimmer switch. Leading-edge dimmers generate less electromagnetic interference than track dimmers because they chop the alternating current waveform at a lower voltage. Electronic dimmers generate even less electromagnetic interference because they use different techniques to control the brightness of the lights. Light-emitting diode and compact fluorescent lamp bulbs generate less electromagnetic interference than incandescent bulbs because they use different technologies to produce light. Incandescent bulbs produce light by heating a filament, which generates a broad spectrum of electromagnetic radiation. Light-emitting diode and compact fluorescent lamp bulbs use different technologies to produce light, which generate less electromagnetic radiation. Filters can be used to reduce electromagnetic interference. Filters work by attenuating high-frequency noise. There are many different types of filters available, including EMI filters, ferrite chokes, and power conditioners. EMI filters are designed to block high-frequency noise from entering electronic devices. Ferrite chokes are simple EMI filters that consist of a magnetic core wrapped around a wire. Power conditioners provide clean and stable power to electronic devices by filtering out noise and voltage spikes. Grounding is an important part of reducing electromagnetic interference. A good ground connection can help to reduce noise by providing a path for the noise to flow to ground. Make sure that all of your electrical equipment is properly grounded. Shielded cables can be used to block electromagnetic radiation. Shielded cables have a layer of conductive material that surrounds the wires. This layer of conductive material blocks electromagnetic radiation from entering or leaving the cable. Keep the power cords of your electronic devices as short as possible. Long power cords can act as antennas, radiating noise. The shorter the power cord, the less noise it will radiate. By understanding the technical aspects of electromagnetic interference, you can take steps to reduce the amount of noise that is generated by your electronic devices. This can help to improve the performance of your electronic devices and prevent problems such as static interference, data corruption, and equipment malfunction. Static interference on an AM radio when a dimmer switch is turned on is a common issue caused by electromagnetic interference. The dimmer switch, especially older trike models, rapidly switches the power to the light, creating voltage spikes and radio frequency interference that the AM radio picks up. Addressing this problem involves several strategies, focusing on filtering, alternative dimmer technologies, and general best practices for reducing EMI. An EMI filter, also known as a radio frequency interference or RFI filter, is designed to block high-frequency noise from entering an electronic device. For an AM radio experiencing interference from a dimmer switch, an EMI filter can be installed in line with the radio's power cord. This filter typically contains inductors and capacitors that attenuate high-frequency signals, preventing them from reaching the radio's circuitry. When selecting an EMI filter, make sure it is rated for the appropriate voltage, typically 120 volts in North America, and current, usually a few amps for a radio. Common types include inline filters, which are easy to install by plugging the radio's power cord into the filter and the filter into the wall outlet. Ferrite chokes are another type of filter that can be clamped around the radio's power cord to absorb high-frequency noise. Different dimmer technologies produce varying levels of electromagnetic interference. Trike dimmers, which are the most common and often the least expensive, are notorious for generating significant EMI. These dimmers rapidly switch the power on and off, creating sharp voltage transitions that cause interference. Replacing a trike dimmer with an alternative type can significantly reduce the static on the AM radio. Leading-edge dimmers, also known as forward-phase dimmers, also chop the alternating current waveform but do so in a way that generates less EMI than trike dimmers. These dimmers start the current flow later in the alternating current cycle, which reduces the abruptness of the voltage transitions. Electronic dimmers, such as pulse width modulation, often called PWM, and metal oxide semiconductor field effect transistor, often called MOSFET dimmers, offer even better performance in terms of EMI reduction. Pulse width modulation dimmers rapidly switch the power on and off at a high frequency, but the smooth transitions minimize the generation of high-frequency noise. Metal oxide semiconductor field effect transistor dimmers use transistors to control the current, providing smooth and continuous dimming without the abrupt switching that causes EMI. These dimmers are more expensive but provide superior performance in sensitive applications. The type of light bulb used with the dimmer also affects the amount of electromagnetic interference generated. Incandescent bulbs, while simple and inexpensive, produce a broad spectrum of electromagnetic radiation contributing to EMI. Light-emitting diode and compact fluorescent lamp bulbs are more energy efficient and generate less EMI. Light-emitting diode bulbs, in particular, have improved significantly in recent years and are now available in a wide range of color temperatures and brightness levels, making them a viable alternative to incandescent bulbs. When switching to light-emitting diode bulbs, ensure that the dimmer switch is compatible with light-emitting diode technology. Some older dimmer switches are not designed to work with light-emitting diode bulbs and may cause flickering or other issues. Light-emitting diode-compatible dimmers are designed to handle the lower power requirements of light-emitting diode bulbs and provide smooth, flicker-free dimming. The physical placement of the radio and dimmer switch can also impact the level of interference. Electromagnetic interference decreases with distance, so moving the radio as far away from the dimmer switch and light fixture as possible can help reduce static. Aim to create as much separation as practical. Cable shielding is another factor to consider. Unshielded cables can act as antennas radiating electromagnetic interference. Using shielded cables for the radio's power cord and any interconnecting cables can help contain the noise. Shielded cables have a conductive layer, typically made of braided copper or aluminum foil, that surrounds the wires and blocks electromagnetic radiation. Grounding ensures that any stray electrical noise is safely directed to the ground, reducing its potential to cause interference. Verify that the dimmer switch and the radio are properly grounded according to electrical codes. A proper ground connection provides a low impedance path for electrical noise to dissipate, minimizing interference. A power conditioner can provide a clean and stable power supply, filtering out noise and voltage fluctuations from the incoming power line. While primarily designed to protect sensitive electronic equipment from power surges and voltage spikes, many power conditioners also include EMI filtering capabilities, which can further reduce static on the AM radio. Look for power conditioners with built-in EMI or RFI filters. The construction quality of the dimmer switch and light fixture can also affect the level of electromagnetic interference generated. Low-quality dimmer switches may have poor internal shielding and generate more noise. Similarly, older or poorly constructed light fixtures may lack adequate shielding, allowing electromagnetic radiation to escape. Upgrading to higher-quality dimmer switches and light fixtures can reduce the overall level of EMI. Before making any electrical modifications, it's essential to consult local electrical codes and regulations. Some jurisdictions may have specific requirements for dimmer switch installations and EMI suppression.